Okay, so theorem 10.6, excuse me. All right, theorem 10.6 talked about if you had a circle where you inscribed an angle. An inscribed angle is an angle that is on the circle itself and it's looking across, where I believe the book definition says the vertex of that angle lies on the circle itself. This is the vertex where the two rays meet. It lies on the circle. And then the rays of the angle are chords of the circle. So they actually have two endpoints on the circle itself. It doesn't have to pass through the center. It doesn't have to. Maybe the center's right here. It could, maybe open up where the opens up where the center is like in between it. Doesn't really matter. But what theorem 10.6 said, and that's the one way I think we did Tuesday, was that if you had this angle here, let's call it 90 degrees. Okay, it doesn't even look close to that. Let's say it's 90. Then the angle that's across from it would have to be half of it. That's the concept that we've had. Okay, that's the idea. Now the homework that they're going to eventually give you will be something like this, where there's like a series of 3 different types of problems they could have. The first one is pretty straightforward. I think the first 3 problems you have in the homework is something like this, where they say this is 70, and they want to know what arc A to B is. So find the measure of arc AB. Yeah, exactly. So if that's 70, this has to be double, and you're absolutely right. It has to be 140. It's double. That's like the first couple problems you have. Super, super easy. Just knowing that the arc itself is always double of the angle, or the angle's half the arc, whatever you want to think of it as. Okay, that's pretty straightforward. Now, the second type of problem, this one caught me off guard because of what they actually gave you. And I thought this was just really clever what they did here. Let's call this X and Y, and let's call this point P, and this is a Z. And the question they had is find angle Z, like find the measure of it. Measure of angle Z.
Would it be 60?
It is 60. Okay, so walk me through it. You are correct. So what do you do?
Since you can move this thing around.
The angle?
Yeah.
Okay.
Well, it's already facing that way anyways. Yes.
Oh, you're like going this way?
Yeah.
Okay. Not quite. Not quite the way you did it. You got the right answer, but not the right method of getting there.
You can make that into a triangle and move the 60 down.
Okay,
And
like
one of the
this?
angles in a triangle is 60, they're all 60.
Okay. Yeah, technically it is an isosceles triangle, but not necessarily that every angle has to be 60 if one is 60. There could be other angles that could be different. So it's not quite the correct reason. You guys are right. Like you have the right ideas with the concept of 60, but I haven't heard the right. It is 60. The angle for Z is 60. So we are getting the right answer, but I haven't heard the right method yet.
Oh,
Think we got it now?
180.
Okay, good. This line goes through the center, right? This goes through point P. So this whole bubble here has to be 180, because this line is 180. That's the central angle, so the arc would have to be 180. So that means this bubble over here has to be a 120, because it has to make a semicircle, right? Semicircle is half a circle. So that would have to be a 120, and then you can cut it in half. That's the idea. That's the concept. That half of the circle is 180, right? Because a full circle is 360, so half of it. And knowing that it's half the circle is because it went right through the center P. So knowing that you could find what's left over, and then you could go from there to figure out the piece that's across from it. Okay, questions, comments about that problem? Okay, last one is very similar to this. Very similar to the last one we just did, where you have to think about like how to find the last arc, the last piece. So this, I should use blue. This was the last one where it kind of combines all of them. Okay, let's call this point O, and this is M and N. And they do something very similar where they say this is 200, this is 80, and it wants to know angle O. Find a measure of angle O. Very similar to the last one and the one before it, that you have to find the arc, and if you have the arc, you can cut it in half. Okay, so what do we got?
It's 80, right?
Say it again.
Is it 80?
It's 80. Okay. So let's talk about it. I believe you should be correct. should be 80 because, or 40, I mean 40. So, but here's the idea. This arc would be 80. Now, why that arc has to be 80?
That's what I was making.
Yeah, because the idea is that this whole arc here, or I guess the whole circle has to be 360, and what you have already is 80 and 20, so that's 280, and you were missing this piece. That piece that adds with 80, or 280 I should say, has to make 360. So the angle that was missing was 80, so you're correct on that front. But then what I heard was you have to cut it in half, which is 40. Then that would be the number I'm looking for. Okay, that's a majority of how you're going to use 10-6. Like I'm trying to show you every style of problem they're going to give you. This one problem doesn't have a lot of algebra 1 in it. It's just solve. The big thing you have to realize is it making a full 360? Is it making 180? Or is it just, do you have the number and you can double it or cut it in half? Do we feel comfortable with those 3 problems? A little bit better anyway, now that I'm not just turning you loose on them. Okay, all right, let's move on. Let's go to the second theorem today, which was 10-7. This is where they have a ton of algebra problems. And just from the look of what they gave you, it's very apparent what they want you to attempt to do on these. So let me show you an example they have. So, all right. So here's theorem 10-7. 10-7 said that if you had an arc, let's say this arc over here was, I don't know, let's just make up a number like 50 degrees. That arc right there. And you drew an angle across from it, that would be half, so this would be 25. But what theorem 10-7 said is that you could actually move that wherever you wanted. So I could put another angle over here, as long as it's looking at the same arc, it's still half of it. So it's still 25. That was a weird back door or something?
She needs them.
Is it locked?
Yeah.
Come on.
Knock.
Yeah. What's locked?
Yeah, that was locked.
Okay. Sorry, Nels. All right. All right. Everyone understand 10-7 though? That it doesn't matter what angle you have, as long as it's looking at the same arc, it's always half. So I could actually put this angle wherever I want. So I could have like multiple angles looking at the 50, and you just cut them all in half. Okay? All right. Now, what the problem that they're going to try to give you on this, what I've seen for the most part, the first one is very straightforward. They did something like this. They had their angle, they had it like this, they had that, they had this as 40 degrees, this was, let's call this A and B, this is C, and let's call this D. And the question is, they had a series of questions about this one picture, and one of the questions was, find the measure of arc AB, and find the measure of angle D. Like that was a series of questions that they had about this picture. So this is like the easy one that I consider. Okay? So just looking at this, what would be the arc from A to B? 80. Okay, because if that 40 is here and it's looking at that arc, you double it, so it's 80. And then what's the measure of angle D? 40. Okay. So that's the easy part. That's the part that I don't find that anyone would really have any struggles with now that you know the property, right? The problem is, it's the second question that they throw at you, and suddenly it just like throws you in the deep end. It's way more difficult than this one, unless you kind of have the understanding of what you're doing here. So they have a ton of algebra on this problem where they do something like this. This is 3x. This is x plus 5, and this is 80 degrees. Okay, you're going to get decimals, don't get me wrong, there's going to be a couple problems that will potentially have decimals like this one. But what you need to do is you could, if they give you the 80, you could set each of these angles equal to 40. Because it's half, right? It's half the arc. So that is considered easy, but they don't do that in some cases. Or they're like, oh, that's 80, so this is 40, so set 3x equal to 40, solve for x, or set x equal to 40, right? But they don't do that. This is what they do. Yeah, that's what you have to do. So the trick is, like on that problem where they don't even give you the arc across from it, you can just set those two angles equal to each other because it's this situation where they're looking at the same arc, right? So they have to be the same number. So on that problem, you just have to go, okay, 3x is equal to the x plus 5. And then, subtract this over, that's 2x equals 5. And then you divide by 2 and you get x is equal to 2.5, right? And you're going to get decimals, as I said. But the idea is that that's what you have to do on that problem. But you're thinking, okay, well, that isn't that hard. But then they throw in a ton of other stuff on the picture to mess with you. So they're throwing the x and the 5x, and then they throw in this little arrow thing, and they say this is 7w plus 9, and this is w plus 15. And they're throwing all this extra stuff in there to mess with you because they want to see, do you know which ones are equal to each other? So the x obviously are equal to each other, and then these two are equal to each other because this is looking at the same arc over here, wherever that arc is. They are looking at the same arc, so you can set the w's. But the problem is you're like, okay, well, I can just look at the letters. They're giving you the same letters. Yeah, but maybe the problem just has all x's in it. So they really want to, catch what you're doing and how you're setting it up. So whatever it is, you could, if they're looking at the same arc, you could set those equal. If these two are looking at the same arc, set those two equal to each other, solve for w. They might have you plug it back in and actually tell me what the angle is. So if you had to, if I had to find this angle right here, you could take 2.5 and plug it back in. So that'd be 7.5 for that angle, whatever it is. Okay, questions on 10.7? Okay, bless you. I consider that problem, the ones that they're going to give you, far more difficult than the first ones. Because you have to do a lot more work, you have to do a lot more interpreting because there's a ton of stuff going on in the picture and you have to kind of figure out what parts are equal. Okay? Alright, now, the next one's pretty straightforward. These are the ones I really walked you through yesterday. These are 10.8 examples. .8 had examples like this, where they had pictures like that, where if an angle is looking at a diameter or a semicircle, whatever they want to call it, this angle has to be 90 degrees. Okay, that was the theorem that we had for theorem 10.8, right? It said if an inscribed angle intercepts the diameter or semicircle, then its measure is 90 degrees. I think that's the exact wording that they used. Okay, so knowing that fact that this has to be 90 because it's looking at the diameter, that's the inscribed angle, they don't have to mark that anymore. You just have to know that it's 90 if that's an actual diameter. And then they'll throw in problems where they're going to give me numbers in here. But again, remember, because that's a diameter, that forces that to 90. So let's do an example here. Okay. So the example that I saw for the most part, I don't think there was really no other different style of problems. They pretty much did the same thing every single time. They did something like this. 2x plus 10, x plus 50, and they wanted you to solve. Solve for x, plug them back in. Maybe they even had angles in here in the corner, so let's call this A, B, and C. And the question is, find the measure of angle C and find x. That's the question that they have. Okay, so if that's the question, then what you have to do is you have to know that the two angles that are in there don't have to be equal to each other. They're not equal because it's a right triangle. That is supposed to be the center dot. Sorry, it's a really bad one. Question?
Would you do the 2x plus 10, x plus 50 plus 90 equals 180?
Yeah, you could do that. So that's one way to do it. So you could throw in the 90 in here because you know that that's the center. So then you could add up all three to make 180, right? That's one way to do it. So if you really like that, do it that way. X plus 50 plus 90 equals 180, right? It is still a triangle. Triangles have to add up to be 180. You could do it that way. Because knowing that the other angle was 90 because of that whole center idea. Now, the other way you could do it, because there's always two ways, you could just add those two together, 2x plus 10 plus the x plus 50, and just set that equal to 90. These two have to add up to be 90 degrees, because in theory, it's the same math, because if they add up to be 180, then 90 plus 90 make 180. So it's the same concept. So either way that you like that problem, you could do that style. But it doesn't really matter. It's going to give you the same answer no matter which one you pick. It doesn't really matter, because how I get from here to here, you just subtract the 90 across, and it's the same problem. But again, doing the math here, this is what, I'll just do this bottom one. So this is 3x plus 60 equals 90. Subtract this across, I get 30. And it looks like my x is 10. So that answered the first part. Find x, it's 10. Now, what do I have to do with the 10? Plug it back in. And you have to plug it into the right angle. They wanted angle C. So angle C in my case would be 60, because I have to plug the 10 back into it. So angle C is right here, so that's 60. This is 10 plus 50. And this one would have to be 30, because 2 times 10, which is 20, plus 10 is 30. So 30 and 60 make 90, and that's 90 already. So we're good. And they could even go even further. They could say, okay, find the arc from A to B. Find the measure of arc AB. Okay, so now they can mix everything together, because if this is actually 60, like 60 degrees when I plug in the 10, now you can find the arc that's across from it, because that would have to be double. So this would have to be a 120 degree arc, even though it doesn't look like it. Questions, comments about the problems we've done here? So there could be a series of questions about that one. I don't consider this one to be difficult like the other one. The 10-7 one, I just don't like the pictures they give you. There's too many things going on. I just don't like it. But again, the only reason why we know that that's 90 is because it went right through the center. So if they mark that as a 90 degree angle, you know that somewhere in here is the center of that. That's the diameter. So you have a triangle, right triangle. Okay, we're good with 10-8. That was the theorem 10-8. Correct. 10-9, last one today, and this will be my last example before I turn you loose. We actually have some time to work today. Homework will be due Monday. And we'll be back out there for a little bit. All right, the last one, the last property they talked about was 10-9, and it talked about if you were to draw a quad in a circle. Okay, a quad in a circle. It doesn't have to be a rectangle, it doesn't have to be a rhombus or a square or a trapezoid. It can be just a random quad. But what they say is that if you have a quad that is inscribed in a circle, that means every vertex is actually on the circle itself. That's what it means to be inscribed. Then the opposite angles are supplementary. The opposite angles. So this angle here and this angle, the one that's across from it, are supplementary. They're straight across. So they're not equal, as you can see by markers. This one's small and that one's kind of big. But they have to add, these two have to add to make 180. That's what we're doing. And same with the other two. That was the property we had yesterday. That was what 10-9 said. They have to add to make 90 degrees, or 180. So let's call this angle A, and this is angle C. You could add them together. Measure of angle A plus the measure of angle C has to make 180. That's the concept. And pretty much, they just give you algebra problems for this one. They don't really even make it that difficult. That, you know, they'll just give you some x's, and then you just add them together and set equal to 180. So I'll do an example here. All right, so here's my circle. Here's my quad. Let's call this 3x plus 5, and this is 2x minus 10, and we can solve for x. And then you can plug them back in, you can find each angle. Okay, because again, if this is truly a quad, which it is, there is 4 sides, you could add these two together to make 180. 3x plus 5 plus 2x minus 10 equals 180. That's saying. So if I add these together, that's 5x minus 5 equals 180. That's adding numbers and variables together. Add this across. 5x equals 185. And if I divide, what is that? A 3 3, 5, 37 degrees. Divide it right in my head. And then you can plug that back in and you can figure out what each of those have to be. So if I were to like, maybe they wanted this angle up here, and you had to plug the 37 back in, fine. 2 times 37 minus 10. So what is that? 4, carry a 1, that's 74 minus 10, so 64. 64 degrees. And then the other one would have to be whatever adds with 64 to make 180, so 114 or 116 in. So if you were to plug the 37 in the other one, you should get a 116. Okay, questions with any of the problems that I've done on the board today? Okay, anyone that you want me to go back over that you weren't quite sure of? That maybe I went too fast or I erased it and you just didn't quite get it? Okay, don't be afraid to ask questions today if you haven't. You can move around, you can sit wherever you like today, but we have new homework. I'm going to make it due Monday. Not that difficult. I think this is by far way easier than some of our other homework that we've had recently. So it should go pretty quick. I don't even know if you'll need a couple days to actually work on it, but it's due Monday. But here's your page numbers here. I might just put it in the middle of the board here. All right, so it's page 727, numbers 1 through 3, 5 and 6, 8 through 13, 17 through 19, and 25 through 29. So I kind of just hopped around the pages a little bit, kind of picked a couple problems here and there. I tried to pick a couple that were just about theorem 10.6, a couple that were just about 10.7, a couple about 10.8, and a couple about 10.9. So I try to just pick a few, that way you get some practice on it. Now remember, in about a week we should be through chapter 10, because we only have, I think, 2 sections left. There's one about area, there's ones about certain angles on the inside when you have chords and stuff crossing in tangent lines. So we'll probably be done in about the next week or so. So I'd be expecting a test maybe in a week and a half-ish. Okay, and in that time frame, somewhere at that point we have MAPS testing coming up. So I think for me, MAPS testing is like either the first week of May or it's the second week of May. So kind of keep that in mind. I'll kind of warn you the days leading up to it that you'll need your Chromebook and stuff, but I don't know if it's necessarily next week. It might be like the week after. I'll have to look at the calendar what day they had it set. So just be kind of aware of that. Okay. Other things to announce today, student council applications are going to be due Monday. I think we have signs up everywhere around the building. You can pick those things up in the office. I think the election we did yesterday, if you did not get to vote for student body president, unless you're a senior, you don't vote, but for a regular class, if you didn't vote for the student body president yesterday, make sure that you go talk to Jan today or send her an email and kind of vote. There's only 2 candidates that were running yesterday. So we need to vote on that, and I think we'll hopefully announce that by the end of today, so that way we know. But there you go.